Hello everyone, welcome back to my channel, Biomathematician. Today we are diving into the world of statistics to explore two fundamental concepts, the mean and standard deviation. Whether you are a student brushing upon your math skills or just curious about how these concepts apply in real life, you are at the right place. Understanding the mean and standard deviation is crucial in various fields, from science and economics to everyday decision making. So, what do we exactly mean by mean and standard deviation? Let's start with the basic. Mean. Mean is one of the most fundamental measures of central tendency in statistics. It provides a single numerical value that represents typical or average value of a set of numbers. So, for calculating mean, we have to sum all the values of the dataset and dividing it by the number of the values in the dataset. Next is standard deviation. Standard deviation is a measure of spread of the dataset. It quantifies the amount of variation or uncertainty in the data point. Low standard deviation indicates the data points tend to be close to the mean, while higher standard deviation suggests that the data is spread over a wide range of values. A standard deviation can be calculated by first calculating the mean, finding the difference between the values of the dataset and the mean, and then squaring the difference, finding the average of the squared difference, and then finding the square root of the average. So for our experimentation purpose, we have this toy dataset, which represents the blood glucose value of different individuals. So let's start with our programming. So for all the purpose for calculating mean standard deviation, we will use NumPy. NumPy is the fundamental package for scientific computing in Python. It provides support to array and mathematical functions to operate on these arrays. Let's first install the NumPy on our system. For installing NumPy, if you have Python in your system, you just have to type this command pip install NumPy. So it will install NumPy on your system. For my system, it is already installed, so it shows this message. Let's start by calculating the mean. First, we import the NumPy, then we calculate the mean of the data. So for import, we will import the module. Then we calculate the mean. For that, you have to use the mean method of NumPy, and we will put the data here. So we have calculated the mean. Let's see what is the mean of our data. So it is around 109.45. Next is standard deviation. For standard deviation also, we will first import our NumPy module, and then for standard deviation we have another function in NumPy, that is std. So our std is found to be around 13.41. Mean and standard deviation can also be used for standardizing the dataset. Standardization is also known as Z-score standardization, is a pre-processing technique used in machine learning to transform features so that they have a mean of 0 and a standard deviation of 1. This is a kind of similar to normalization also. So this process centralizes the data to around 0 and scale it making it easier for machine learning algorithm to interpret the processes in the feature, interpret and process the feature. For that, we have to find the standardized data. Find the standardized data, we have to find the difference between the data and the mean, and then dividing the difference by the uh, uh, dividing it by standard deviation. Let's do it. First, we find the mean of the data, similar to above example. Then we find the standard deviation. Then find the standardized data. We first find the difference between the data and the mean, and then divide it by the standard deviation. So let's see what we have this data standardized. So here we have the standardized data. So let's see what is the mean of the standardized data. So first we round this to 2 decimal. Here is the standardized data. Next, let's see what is the mean of this standardized data. We will round it because it is near to 0, 2 decimal. So it is 0. Mean is 0. What about the standard deviation? So standard deviation is 1. There are limitations also for mean and standard deviation. They are very well used in statistics measure, but it is most commonly used for normal for norm, normal normally distributed data. It has some limitations which we will see here. So mean is and standard deviation are sensitive to outliers, and they are not robust for skewed data. So let's have an example where we have an outlier. This is the outlier 250. So let's calculate mean. We have just added this. So we will see the effect of adding an outlier on our result. So we will calculate the mean, p dot mean, the data. So mean for this data having an outlier is 121.17 and standard deviation is 40. Whereas for the original data, we can see the mean is 109 and the standard deviation is 14. So we can see that the mean and the standard deviation has changed a lot in by just adding a single outlier. So you can you can check also that how uh, adding multiple outliers can change the distribution. So mean and standard deviation is very sensitive to outliers and not robust for skewed data, but most of the time it will be useful for general use case. So I will upload this um, notebook on GitHub and will also add the uh, I will add the link of GitHub link for this in the description of the video. You can get it from there. Thank you.